in the AI for AI Game Challenge webinar, Introduction to Machine Learning in Game Development from 9 a.m. to 12 p.m. today, where we will explore how AI and machine learning plays a part in creating a fun gameplay environment. In addition, we will also unveil the Game Design Challenge competition details and how you can sign up for it. So the top teams will stand a chance to win exciting prizes, which will all be revealed at the end of the session. Now, just some kind reminders: you may turn off your video during the session unless requested to. Kindly change your names to the name that you registered for ease of attendance taking, and please take note that SUTD will be taking photographs, video recordings, and audio recordings of the participants during this virtual event. The images and recordings will be used by SUTD for educational, informational, and publicity purposes. Now, if you have questions along the way, kindly write them down somewhere first before we unlock the chat panel. Or alternatively, you can also use the Q&A panel that is available right there, right below, for you to ask questions, and we will address them accordingly. All right, so without further ado, I will now pass my time to our trainer for today, Mr. Danny Chow. Now, allow me to introduce our trainer for today. Mr. Danny is the lab manager for SUTD Game Lab and is a passionate game developer and believes in making a better world through game technology. He joined SUTD Game Lab in 2017 and has over 10 years of experience in game development. In the last 10 years, he has worked on projects that specialize in virtual reality, augmented reality, and published over 8 mobile games. So, Mr. Danny, please.
Hi, thanks, Ryan. Hello, everyone. My name is Danny, and yeah, he had really introduced me to everyone. So I'm very glad to see that everyone's pretty much there's about 100 something of you guys in here. So just to give you a bit introductions of what I'm doing in Game Lab, right? So this is share my screen. Okay, so hopefully everyone can see my screen here. Okay, let me introduce myself again. I'm Danny from the SUTD Game Lab. And just to let you know that these are teams that we've been developing the web media content for machine learning and also for these demonstrations. So first of all, I'll introduce my director. She's Professor Doreen. So she's the one who's actually she's an ex professors and expertise. Her expertise is mostly in AI for music. That's me, team lead for this project. And I have my other colleague, Ziwei. He's a game programmer. So yeah, he worked on. He also helped me out with some of his programmings and the contents for this demonstration. Now moving on. Now let's talk about our game lab, what we've done, what we've achieved right here. So first of all, the game lab was established in 2007 as an MIT game lab. So we pioneered in the game experimentations and training. That basically, if you want to put Singapore as one of the as a sport, to be in the game industry itself, just basically introduce Singapore to the world. That we have a vast variety of games that's being developed in Singapore. So we jumped into that with MIT. And then the second thing that we also conducted GIP, which already has passed, but since 2018. But with this program here, we basically set up a sort of like a studio environment within SUTDs, and then we invited students from different institutions to come over here as interns. They worked, we gave them, they set up basically the environments as like a game studio, and they worked and developed, and we also invited the industry partners like Ubisoft, Microsoft, and some of other game industries partners as well. They gave me as a mentor. And then at the end of this programs, the students or the interns actually develop commercial ready games, and some of them actually successfully has published some of these games out there. So you can check out some of these games. I think called I think it was a few games. I couldn't remember the name, but you definitely will be this. If you go to some of these game events, you may have noticed their names right there. I think it's called Battle Brew or something. I think there's a name called Battle Brew. So yeah, it's one of the groups that actually successfully made some of the games right here from GIP. And also, it comes to our goal. So what SUTD Game Lab aspire to do? So SUTD Game Lab basically we develop innovative and inspiring games in the field of education, artificial intelligence, VR, AR, and also in healthcare. And our expertise are mainly in gamification. So what it means is that we mainly work in games that are serious games, that's like simulators and robot trainings and robot simulations and other things. And the thing is that most of the times all these research programs are kind of a bit boring, but we added a bit more on another layer that is the gamification to make it a bit more interesting. Another thing is that we want to establish game labs as one of the game research and game research and developments through collaborations with other industry partners and so faculty. So yeah, so we work a lot very closely with our faculties within SUTD. So yeah, with their research, and then we make games for them, and then through the gamification. And lastly, we want to promote SUTD Game Lab as a center for cutting-edge game developments. So through something like this, like webinars, and workshops, conferences, and also we mentor. So we actually do have interns actually join game labs, and then we mentor them and we teach them what they need to, prepare themselves to work in a game industry. Now we get to the real part, machine learning for games. So this is what you all came for. So some of you might have already heard that about machine learning, but for those who are not initiated, it's that machine learning for games are pretty much a very new field right here. So machine learning is like another branch from AI. So what it really is. So basically, machine learning is a study of computer algorithms improved automatically through experience by use of data. So a lot of data, pumping a lot of data, and you get machine to learn how to react, how to decide what to do next. So basically, this really means training using a whole bunch of data. Now, what I need you guys, everyone, to do is that if you're going to follow me, before we start to introduce you more about machine learning, we're going to do a little bit of setup right here. So I need everyone to go to this website, right? So we're prepared. But I'm going to do this hands-on so you can follow me as I'm doing on screen. So let me just switch my screen. So yeah, if you go to that address, you definitely will see this website. So, or you can see right from top right here. Okay, so what we need to do first is that we need to set up the environments before we get to the hands-on part about how to treat agents and show you how you can actually make games using machine learning. So the games that we're going to use, we're gonna get you guys to everyone to install today to set up. It's called the Get Cheese. Now, we really know that the Get Cheese sounds like more like a mouse and cat kind of thing. So yes, it is. So we'll get to that part later. But I need everyone to go and set up the environment first. So what I need you to do first thing of all is that click on this installation guide. That's the link. I believe that when we make these announcements about the webinar, we would like to get everyone to install Unity game engine before this webinar. But to those of you who have not installed yet, that's fine. You can basically click on this link right here, and then it takes you right to the download. So if you click on here, and it takes you to the download for Unity. And then you're just gonna automatically download it. And once that completes, you just basically open the file. And you just see this thing right here. So it's, then you just click next and just install it. Now this installation will take about 15 minutes, depending on your network speed. But I would like everyone, so if you don't have Unity right now, I would like everyone to follow it. So I was just gonna, as we allow everyone to install for about 15 minutes, I'm just gonna introduce a little bit more about machine learning and what we're gonna do right here. So I already have Unity installed, so I'm just gonna let everyone to proceed first. Let's return back to that. Okay. Now, some of you may have already heard or maybe even experienced machine learning, but essentially machine learning for games are if you've seen it before, it might look something like this. So one of the first things that you might see, this is very familiar to almost everyone's, and in this era right now, this is Dota. So there's really there's a competition right there, or they see that's like there's a competition for AI. So people uses open AIs to develop and train agents to master the art of playing games without human interventions. And these AIs are trained using real data from the top players around the world. So these are all these champions, and then they actually donate they actually gave the data to the OpenAI team, and this guy they train the agents to compete against the top players in the world. And yes, of course, without questions, then the OpenAI actually beat most of them hands down, and that's really good. If you watch the videos, it's actually quite impressive. But then see how actually they make the decisions and how they actually fight against top players. And the other things about the behaviors is about machine learning is that in most of the time, in those old days when we develop AIs for games, usually are quite predictable. So whenever because they are codes and then you program it with certain patterns, and most of the time, most people can you can make all the patterns after a while, and you definitely will be able to beat the AI because that you know how the AI is going to work, and that because of you can predict how it work, how it's going to move. But machine learning is making it a little bit harder. So the OpenAI disadvantage of having OpenAI is that OpenAI makes decisions based on what's the input from the environment. What that means is that any movement, every single character that moves in that environment the AIs will take that and make thousands of calculations and decide what is the most optimal moves against the certain entities in that. So pretty much the same as what we humans are doing too. We take all these information and decide what we need to do next and do our best to overcome the challenges. And then the other thing, interesting one is that this one right when I show right here is the Mario. So this is a very, very old Mario game, but what is so good about it is that you can see how this actually is a visualization right there. And you see that's on the left-hand side, that's like this is what the visions, this is what AI is looking. So you can see that there are blocks and there are panels, and there are like platforms and things. So this is what the AI is getting the input from. And you can see that based on that input, it's deciding what it's supposed to do, like, what button to press, like A, B, X, Y, or up, down, left, right, and how it's supposed to move in the world. Of course, it's not going to avoid, it's just really avoiding the enemies and not going to kill any one of them. But this is just really to show you to illustrate or show you how the AI actually making decisions. So yeah, you can watch the videos of these two and just really learn about how AI actually, how machine learning is actually can be used to do a few things like in competition, and this is actually to like test the level to make sure that the levels is playable. Okay, so if you want to, well, basically there are a few videos I can show you. Let's see a second right here. Not this. So yeah, so this is a video. You can go in there, just type in like Mario. So Mario. So this is the video I just showed you in the gift. There's another one that is OpenAI. This is actually another interesting one. So this AI is not an OpenAI game. So this is the one about is you have two AIs, two sides of AIs, and the blue and the red one. So the red one's supposed to capture the blue one, and the blue one's supposed to block their path so that the red AI can't do things. So as you can see, as it progresses, that this is going through like literally thousands of training, and after a while, you can see the blue ones actually figure out that way to block, to prevent them from catching them is to take those blocks and just block the path. And now the reds are totally locked out; they can't even go in, and that's pretty cool. And you can see that the AI can't do anything about that. But then the developers say, what if we add a ramp right there? And what's the AI is going to do? So same thing, going after a few thousand over iteration. the AI, the Ray AI actually figured out that now you can actually use a RAM and put a RAM to the wall, and it starts climbing over the wall, and there you go. And it starts to it starts to catch the blue ones, then it starts to corner the blue ones out afterwards. So here you can see that how machine learning actually can help AIs, from this demonstration you can see that machine learning can evolve, right? Just like how humans is that how we solve solutions. So we find ways to complete a certain task with the optimal way, right? I believe some of you guys have some issues with the Unity installation. So generally, I think the installations is that if you install it, if you ask for the for any licenses, then you can choose the personal license. You don't have to choose the pro license. Just choose personal license, and that will do. Okay, so we're done with this, and now we can move to the next one. I'm sorry, not the break yet, but so we're gonna move back to our installations. Okay, so already 15 minutes passed. Okay, so if you have all Unity installed, so the next step is you have to install Python. So what Python? So most of you will also know about Python too. I'm pretty sure you all know about. It's like a programming language. It's a very simple programming language that you use for the program from simple hello world, and also mostly used in machine learning, right? So you've heard about TensorFlow, yeah. So you use Python most of the time. So, but here we use Python mainly because we need the Python to as a communicator. So because when we run the Unity, and then we have the trainer scripts, and we need Pythons that to run the trainer script in order for us to train the agent. So this is actually very important. Then instructions will go very simple. So what you do is that you click on this link, right? Download the package, download the installation file, right? And then when you open that file, you will see the screen right here, and make sure that you click Add Python 3.7 to path. Now, this is very important because if you miss this one, you will not be able to run any of those trainers later on. So make sure you choose this. And the next part is just click install now. Now the installation is fairly quick. It's about a minute or two. And when you're done, you'll see the screen. Okay. Or just going to wait for about 1 minute, and let's give everyone about 1 or 2 minutes to install it. We'll proceed. Okay, so once you've come to the screen, where you got set up so successful, and then now what you need to do, now you have to open up a terminal or a command prompt. So what you need to do here is just do Windows key or R, or you can choose to type here and type CMD. So CMD that'll do, and it'll give you a command prompt, right? So that opens up there. And then the next thing you do, what we're going to do right here is just to make sure that everyone's, all the installation of Python is successful. So we just need to do is type Python, right? And then double dash, right? And then type version. Now, if you follow the instructions or my steps, the Python that we can download, you should show the version 3.79. And if you get 3.79, then it's all good, and we can move on. Okay, so let's get this out of the way. Now the next step is, now here we're going to get the good part here. So the next step here is we need to download the GameLab ML Agent Toolkit. Now, and the ML Agent Toolkit, it's actually it derived from the Unity ML Agent Toolkit. So we're actually using the components from ML Agent Toolkit, but we added our stuff, our own developments and our own games in there. So we package the whole thing, and then we're just gonna get you guys to download everything here, and then we can proceed from there. So to download that, click on this link, it takes you to Google Drive, right? So that, don't worry about it. You say that you couldn't preview the file, but you could just click on this right here to download the package entirely. Just download anyway. Don't worry, there's no virus. It's absolutely clean. I can guarantee that. Right? So it takes probably just a couple minutes to download, depending on network speed. It's 100 or about 100 megabyte. Yeah, so a couple minutes. There we go. We're done. Now the next thing, I need everyone to open up their where they download the package. So usually it will be in the download package download folder. So it's the download folder. It's the ML Agent Release 17. So you can unzip it. Usually I'll just double click. For Windows, it's just very easy. Just double click on that, and then you click on this folder. Make sure ML Agent 17, or if you have to unzip, just make sure that you unzip to just follow instructions to the document folders. I choose documents because that's the safest way to do things. To usually put in stuff. Because if you choose to say put into C drive, you may require some elevated privilege in order to install it or to put in some files right there, and it can cause some issues through this demonstration. For this demonstration purpose, for this guide purpose, for this exercise, we're going to use documents, so that'll be easier for everyone to follow. So choose document. And you can basically paste it right here if you want to, or for me, I've created another folder. I just go for development, so that'll be easy later on for me. So I just do that. So just paste it right here or unzip into whatever folder you want to. But just remember the location. Takes about 2 minutes to unzip. So yeah, so let's wait for a bit. Yeah, so just give you a little bit background about the games is that so it's more like what we want to do in this is that the games we're going to show you the demonstrations about how the machine learning is going to decide what based on the goals and the rules that we set right here. So the games we're going to showcase it, and we want to display that very clearly, that to say that there are few goals, there are few things that's a task, code task that the agents need to complete, and how we can use certain like reward and penalty to encourage the AI to make certain decisions of that. So okay, so we already have the file unzip. So now we can actually go in there and start up the project file. So go into the ML Agents Release 17, choose project, assets, cat and mouse. Yes. And choose the scenes. And then you double click on this cat and mouse nudity. If I'm going too fast, the instructions are still inside the web page right here. You can see that which location to go for. And then open up the cat and mouse. So just wait for a little while for it to start up. I'm sorry, some disturbance down here. So once we have so just waiting for it to import all the scripts and other packages in there, and then the next thing we need to do afterwards is that we will have to set up the translator. So what is what we call it? There's a package that we need to install later on. So just bear with me for a bit. Yeah, I think there's some questions about you're not able to see what I'm doing. I'll just finish it. Okay, so can you guys see better? So now I have things running right here. Can you see the Unity? Yeah, so if you follow the instructions from the Chrome share or the down the game that ML Agent Toolkits, you should be able to get up to this point now. Okay, so we have all we've got this thing started up. Give me a second right here. Okay, so once you've got this, and but you're not going to be able to run anything yet. So don't click on play buttons because we are not finished with the installation. So the next thing we need to do is download we need to install the package, what we call the com.unity.ml package. Now to do it, follow me. So we just go to Windows, go back to your media editor that you open. So let's go on Windows, click Package Manager, open up, and then we'll have a plus button right here. Just click on this one. Oh, just wait for a bit, scratching packages. All right. So what you need to do is right click, add package from this, and then go back to the folder that where you install unit, where you download the ML agents package. So here, we've got ML agent 2017. And you see that .com and it's got com.unity.ml agent. So this is what you want to say. So double click on that, and then choose package JSON, open up, and it will install the new package. So you should see the ML agents and ML agents extensions in the list. If you don't see that, try to do the same. Try to install that. Make sure that you have these two in it with this version, 0.4 for the extensions and 2.0 for the ML agents. Once you got that, and then we're good to go. So we can close it. And the next step, we need to set up. This is the last part we set up. So this is actually very, very crucial. This is the one that we create the environment. We make the link, the hook, so that the Python will be able to communicate with Unity. So open up your please open up your terminal. So what you should do is just go to the ML agents 2017. That's where you unzip your the game folder, the project folder, sorry. And then what you need to do is to make sure that you're not selecting anything here, and then you just right click and choose Open PowerShell Windows here. So some of you may not have PowerShell. You might only have command prompt. So just click this one, and you should see this terminal. In my case, I have a PowerShell. But for those of you who are not able to open PowerShell or even do not see the command prompt there, no worries. So do the same thing. You type CMD, and then it opens up a command prompt. Open up. So and then navigate to the right folder. So the easiest way to do this is that you open up the File Explorer, Windows Explorer, and then you choose navigate to the folder, and then copy that directory, come here, and then just do and make sure you choose the terminal that you open, the command prompt, and then just do a paste. Sorry, before that you do CD, and then you paste it, right? So then you just enter, and now you move to the new to the exact locations of the folder. So once you've done that, now what we need to do is the type we're going to use a command. So the command that we need to do is that we need to it's a PyTorch, so we need to install this. Make sure that we need to do this. And make sure that you type this incorrectly. We don't want to install the wrong versions or anything that's not related to this demonstration. So we do that. So right click and we just type the command. For me, I'll just paste it. Just run it. And yeah, so what happened here is that I already have some of these packages already installed. For those of you, this will be quite it will take probably about 2 to 5 minutes depending on your speed. So we can just wait for a little bit right here. But once you start to see, but if you start to see like warning, you're using PIP version 2.11 something, this thing, don't worry about it, just ignore it. It's just telling you that your versions of the whatever version that you're installing is older. But that's exactly what we need to use. We can't use anything that's the latest, the later version, because that's not gonna work for this demonstration. Okay, so then the next one we need to run, it's a Python install ML agent command. So this is the one that we set up the environment for the Python to communicate with Unity, and also tell the Unity that that we are setting up you're supposed to run these commands under a certain environment, where the environment contains where this environment contains settings and configurations that is made just for these demonstration. So if you forget to run this, you can still run the Python scripts, but it's just that Unity will not know what configurations or settings that it's supposed to use to train the agents. So this is very important. So you need to run this. Okay, so let's do that. And then we'll just go, I'll put it in the terminal, just run it. And then you're just gonna download a whole bunch of other packages right here. This will take about 5 minutes too, because there's a lot of things to install, and just gonna go through this. And if your network space is fast, that's good, because this is just gonna be a breeze. Same thing. So if you've installed this, and then if you reach to this point where it says warning, you're using pique version 2.11, again, just ignore it. It's not going to do anything. Okay, so once you get to that part, the next step is just really to test it, just to make sure that everyone's and just need to run this command just to make sure that you have installed, set up the environment correctly, and just run the command. And if everything working well, you'll be able to see that ML agents command will dump all that. I mean, basically because they ask for help, so it's going to dump in all this parameters and some of this information about how you can actually use those parameters here. Okay, if you see it, then it's good. Then you're ready for the next step, which is the training of the agent. All right. But before that, we can start to have a little bit of fun there. Now, so what we need to do is switch back to the editor. So we've set up the environments, we set up the translations, the translators, the communicators. So everything's all is in place. Now you can actually run the agent. So what we have here is that the agents is a mouse. It's hidden in the wall right there. But the mouse, we already have some default training file in it. So we just attached it, and then we're just going to run this this agent just to make sure that everything is installed properly. So if you do a play now, you should be able to see the mouse started to move around. Oh, if you get this display no camera rendering, don't worry about it, because I don't put a camera in the project. So what you can do is just choose back to see, and you can see that mouse is actually doing something. So yeah, so this is basically just the default mouse. It's not really doing anything at this point. It's just basically showing you that it's communicating with the Python, and it's actually running, and it's actually basically takes the trainer files, and just basically run through the simulations, and just to, basically right now we can see that it's just really moving back and forth exploring the map and not very much things there. All right, so if you can see this and your mouse is running properly, right, and then you can move on to the next step. And the next step, you guys go back to the webinar. So next step, just click on that, or click back here. So get back to the main page. So the next step, the next page is this, that the training agent. So this is also another crucial part here. Now, just to let you know that we're using a very specific algorithm right here to train the agents and record, and the algorithm is reinforced learning. So to put simply, the reinforced learning, it's you basically train the agents through a reward and penalty. So what it really means is that in simple terms, you're telling the agent, say, okay, I'm gonna tell you the rules, you do the task. If you get it right, I'll give you a reward. If you get it wrong, I'm just gonna penalize you. So in this case right here, the games is called Get the Cheese. It's a game that we're going to tell the agents, which is the mouse, to navigate the map, find a switch that correspond to the assigned color to the mouse. So in this case right here, we have 4 different colors right here. We have red, blue, green, and yellow. And the mouse that we assign color to is red. So we're telling the mouse you're supposed to look for a red switch, and then get the turn on the switch. And after that, the cheese will appear, get the cheese. So so we're going to put in the rewards for every single actions that's going to do right here. So in this case right here, when we put in some rewards, say, get the switch, it'll give you 1 reward point. Get the cheese, which is complete the task, and you get 2 points. Now there's also an obstacle right in there, which is the cat. So the cat is just really something to disrupt it, just to make sure that it's it will not, it's make sure that it's just to hinder its movement, so that if it hits a cat, and then you get penalized, and then here that we penalize it with some points. So let's say 2 points for hitting a cat, and therefore it will just, okay, if it hits a cat once, so after a few hundred of rounds of training, it will start to sort of realize that, oh, if I'm hitting the cat too much, I'll get too much of this penalty. I'm not going to do that anymore. So it will avoid the cat in that. And another thing is that we also put in some, we call it some penalties, to encourage it to move faster, to complete the task faster. That is that's called if I'm not wrong, it's called the existential penalty. So what it means is that the longer you stay in that situation where you can't find, if you stay longer to solve the puzzle, you will get penalty every single seconds. And so that basically encourages the mouse to say, I need to complete this task as fast as I can, so that I don't incur so much penalty over time. A bit more about this later on after the webinar. So this link will be open to everyone. Everyone still, you can come back right here and still read more about how this reinforced learning algorithm works. And then the goal of this reinforced learning is basically is to get the mouse or the agent to come up with the most optimum policies, or we call it optimum movement. So how do you actually complete tasks with the fastest time with less movement? That's essentially it. Okay. Now, so how do you actually set the reward and penalty? So what we have right here, later on, I'll show you how we can do that. So that's we can do that here. Just how I mentioned, right? That's a cat that they have 4 different switches, and there are switches and keys with 4 different colors like that. So it's red, blue, green, yellow. Then the mouse, we can right here, we can choose to tell the mouse that, okay, now your task is to look for only the red switches, the blue or green or yellow. So we can train them to do the very specific tasks and say, I only want to do red, and then we train them, and they'll be the best mouse in the whole universe, and just very, very specializing looking just for blue cheese and switches. Sorry, red switch and red cheese. Okay. So here's some explanation about what these parameters are for, or what is going to do for the values. So here is that you can do the setting later on, but later I'll show you how to do this. I'm going to demonstrate how it can work. So end rewards. So end rewards is when it completes the task, when it finds the cheese. Now the thing is that cheese does not appear at the start of the game. You need to find the switch first. So here we also have to reward the mouse to, if it completes the task, the first task that is to find the switch. So you get the switch, turn on the switch, and then the cheese will appear, and therefore it allows the mouse to complete the task. Right, so we get this rewards, just 2 rewards. So it's very important that you need to put in. Fail rewards, you can say if you need, so this is basically there's a score that we're putting in there, or a penalty that we're putting in there. So it's going to be incurred by the mouse or the agent every single second. So this is the part where you encourage the mouse or the agents to complete the task with the fastest times and with the most optimal movement. Fail by cat. So this is the obstacles. Hit the cat. You give a penalty for this cat. If you hit the cat, it's going to get penalty. And this so to train the agents, let's say, avoid the cat no matter what. Okay. All right. So we can actually begin with the training. So now what we're going to do is go back to open up the terminal. So I believe that the same terminal that you'll have right there if you never close it. So just if you close it, just reopen it and go back to the same navigate to the same location of the ML agent release 17. Okay, so right in here, the mouse should stop. Okay, cool. Oh, before that, we need to set the reward and penalty. So because we can't train them if there's no reward, so we have to train the mouse to do that. Now, what I have here, you notice that it's like, oh, why do we have 4 different map right here? Okay, so each of these correspond to different colors. So these mouse right here this one is the red mouse. This is the blue mouse, yellow, and green. So what we're going to train this mouse to do is that these mouse we're going to do but what's going to happen is that we're going to train this mouse, and then the mouse is going to be all the 4 different sign color mouse will start to go around and hitting the switches and cheese and it basically it will train and try to figure out what is the most optimal way of getting to the goal. So to do so, let's do it. So let's click on this prefab, which is a small cat and mouse area, and choose the mouse. Okay. Now here in this part here, we could so here we just need to scroll down a bit, and you can find the cat and mouse scripts. Then you should see it right here. Don't worry about the rest. Just concentrate this part. So the first one is the red mouse. So we have the scores. Now to demonstrate that's how it's going to work. So we have given the score right here. So just for this exercise, I'm just going to put 1 for getting the cheese, 1 for hitting the switch. Fail to get to the goal. So this is something that it's going to incur every single second. So we're just going to give them, for example, second 1 that's pretty high, and say you got to complete the task as quick as possible. And so here is fail by cat reward. So we're just going to give a penalty. So this for this exercise, we just do 1. Of course, this is not the actual settings, but this is where you will learn. Basically, in this exercise, you will learn what are the steps to train it. But when you train yourself, you can always experiment with different values, right, to see what is the most optimal way, or how you actually see. But yeah, so by changing all this value right here, you can observe the behavior of the mouse. But later on, I'll explain to you what those are, how you can do that. So for this demonstration sake, just make sure they put in these values for all of these methods. Yes, because all the mouse will need to have the same scores. So I was just going to do that for all the mouse. Same then. All right. Then we got next one. So just in case if you wonder that how do I actually assign the color to the mouse, so you can just choose right here the mouse color and then you choose whatever color you want to assign to. And yeah, and then the next one, the last one, last mouse. Okay, there you have it. So you have now, you can set all the rewards and penalties for all the mouse, so now you can do, so now we can start the training. To do that, please go back to the web page, and there will be a command that you need to run. Okay, so here's a command that we need to run. So make sure you copy that, and don't copy the period, the dot, right? Let's leave the dot out of it. So make sure that you have these properly. Now there's an explanation about the parameters in the command. So there's like the config ppo cat_mouse.yaml, this YAML file that basically is the configurations for a certain settings that what we're talking about just now about the settings that it requires. So they knows that how to train the mouse and how long it's supposed to train, how fast and things like that. This one I don't recommend you to touch it because this will but you need to do a little bit of reading if you want to, but that's for this exercise, so you don't have to touch it and just leave it there. Right, and then run ID. So run ID is just basically means that it's just an identifier. For each time that you run this training, it will generate what they call it a model file. So a model file basically just means that it's a set of instruction which has been optimized to perform certain tasks. So each of these ID right here will just basically allows you to every time you set a new ID, so then it will just create a new model, a different model. So then you can use the ID just to identify which model is, let's say which model is more latest and which model you want to use later on. So because when you train it, you might want to change the penalty scores and also the reward. So you get different behaviors right here. So you want to use the ID, say, oh, I set score with this and this, therefore I use this ID, and then the ID for a different kind of score. So you can use that for comparison later on. Or then later on you say, I like this behavior, so you can choose to say, I want to use it from this ID. So that's really what it really means. Okay, so for this exercise sake, we just choose cat and mouse run. All right, so copy that and then paste it and run that. If it runs properly and you will see as listening port 5004, that's when you go back to your editor and then you just click run. And then you can see that your mouse will start to train and start to move around. At this point right here, you will notice that now it's like, oh wait, it's like now why my mouse look kind of dumb, right? Now it's worse than before. As in the last before the one when you run it for the first time, the mouse at least is able to explore or at least be able to do. It seems to be more lively, and now it's a bit like stay in one corner and not doing anything. In the training phase, it's basically just like say I'm starting from blank slate. The mouse does not know anything at all. So what the mouse is doing right now is that it will make small adjustments for minute movement to see just basically to explore and basically getting inputs like okay, so if I'm doing these, what does it mean? And then and of course the mouse does have what they call it observation or sort of like an eye. So if you click on this mouse right here, you see that you're like red and white line. So what it does, so what is actually called ray cast. So what it does is actually it's casting sort of like a vision for a mouse. So each line is a line of sight. So each time you hit something, it will tell the mouse, oh, I hit a mouse, I hit a cheese, I hit a wall, I hit a cat, I hit a switch. And therefore then it's like, okay, now I know my surroundings. I know what other controls I need to do to make the mouse move, and then what other what is in the map right there? There's cheese, there's a switch, there's a mouse, and there's a wall, right? And now it starts to go around, explore from one corner to another corner, and then see just how big is getting the size, the view, the size of the environment, and then learning right there. Now, so you just let it run for a few minutes, for 10 minutes and 60 minutes, say for example, like 5 minutes, 60 minutes, do like the interval. So each interval will come back, you'll see the mouse doing behave differently. It'll be it will do the first time 5 minutes, just like 10 minutes is like, oh, now it figure out that it's a switch right there. And then after 6 minutes, it's like, oh, now it knows the switch, and now it goes for the cheese. And then afterwards, after 6 minutes, you can see that the mouse is going on super speed. My mouse is like, wow, it's tick, let's just go red, and then switch cheese, red, switch cheese, red, switch, and switch cheese. And I can show you right here what that really means. Okay, just gonna my sorry. Now, so after training for about 5 minutes, right? So you can see that in GIF right here, it's gonna look something like this. Right, it's the mouse I trained earlier before the webinar. So this is so you can see that it's actually still just keep hitting the wall, doesn't know what to do in 5 minutes. But let's see what happened after 30 minutes. Now you can see that the mouse actually managed to find the switch and hit the switch right away. All right, it's just like it appears, see the switch, hit the switch, because this mouse has been trained to look at only the red color switch, and therefore, like you see the red switch, hit it straight away. But see what happens after 6 minutes, or more like 120 minutes. All right, I leave it for 2 hours, and you'll see that now the mouse starts to blaze through the map, like hit the red switch, red cheese, red switch, red cheese. So you have really found the most optimal way of completing the task. So this is what machine learning can do, and is that you just basically tell it to give you rules, certain instructions. You figure a way to complete the task as fast as you can, right? So that's an interesting bit here. Now, that's just like, so you may have noticed that as well, like why this screen right here looks kind of like there's a whole bunch of maps right there. Why do I have so much map? Why do I do that? Well, the reason is because it can actually speed up the training. So what it means is that if you only have one, for example, and instead of having 4 of them, you only train with one scenario. So that's like you're spending the mouse to train on one scenario for the next 120 minutes, and the mouse is going to be like, oh, okay, it's the same scenario, so I'm just going to be very good at doing one scenario. But you don't want that. You want the mouse to be able to work out a solution, an optimal solution, optimal path, optimal movement in all kinds of situations, all different scenarios. So what happened is, what I did is that I created 16 different scenarios. There's more like 20 different scenarios, and you train with the 20 different scenarios. And not only that, the mouse actually able to handle those unexpected situations later on, but it also speed up your training too. Because if you see that training with one scenario, usually what it means is that the mouse will have to get through each scenario takes about 5 minutes to complete, right? Depending on the outcome. The outcome is that if you get to the goal, then it resets. If you're unable to hit the goal, you just kind of keep going around for another 5 minutes. And if you have 4 different scenarios, you're training 4 different scenarios in 5 minutes. You have 20 different scenarios in 5 minutes. So that's actually better in the training too. So it actually speed up the training. And if you want to look at the result right here, like say for example, like this, okay, after a while when you train the mouse, like say after 5 minutes, you'll be able to see something like this. That tells you that, okay, what these numbers are telling you is that, it's telling you that if the mouse is actually learning anything at all. So if the mouse is learning, so this is what we look at. If the mouse is learning well, you should see something, this part here is going to be turned to positive. Positive means that I'm hitting a lot of switches and keys, and therefore I'm getting more positive reward rather than negative, because negative just basically mean here is that it's either hitting the cat a lot, or it's not getting the cheese, or not able to figure out the cheese, because you remember that when I tell you that it gets penalty every single seconds that pass. So that's what really means. So if the mouse able to complete the task, let's say in less than 2 seconds, then these you'll start to see the positive values. How that's going to look like, that's from here, it's very hard to tell. But we have a different tool that's actually very, very useful to help you to decide when you should stop the training because the mouse it learned enough. And that's that the mouse is actually now a pro when it comes to hitting the switches. All right, so what we do is that let's open up another terminal. So we go back to this folder. Okay, so let's go back to this folder, ML agent. Or you can open any command prompt if you want, it doesn't matter. So for me, I'm just going to do a PowerShell for now. And I'm just going to do is type tensor board. Right, there's also the same instruction that you get from the website. It's the same. It's the same command. So to do a log dir. So basically just say which directory I want to go for to get the result. Because every time we run the training, there's the results or the result that you would generate a graph and call it the results. So we can actually be able to see how it actually perform over time. So you need to go to the correct directory. And the directory is called results. So you just run that. And what it does, what it's going to do is that it's going to set up a virtual web server, and that basically just to host the graph. And now that's done, so it gives you the address that you need to type in. So this is localhost 6006. Let's open up your web page. So let's do the same thing. Let's that, and let's type localhost 6006. Enter. And you should see this. And yeah, so because there's not a lot of the result right now because it's only like 2 points, and it's not going to show you a lot, and it's not going to show you much. But if you train your mouse well and it's done correctly, you should be able to say something like this. Let's go back there. And yeah, so this is basically just like train after 5 minutes. This is how it looked like after 5 minutes. It's more like maybe 10 minutes, I guess. Now, yeah, so you should see something like this, a very early stage, and it should look like that. And episode length, and there's 2 things. So these are the 2 things you need to really concentrate. The cursor graph is like a whole bunch of other things in there, which is it's probably not going to make any sense to you. It doesn't make sense to me. So I don't really care about the rest of it. You can read more about what this really means, but for this exercise, we just concentrate on these 2. But because it's going to take quite long to generate that, after like 2 hours in order to see what the end result. So for this exercise 6, I already have some of this captured. So the first 10 or 5 minutes, first 30 minutes, you're probably going to see something like this. It starts to dip first because it's getting a lot of penalties that it doesn't know what to do yet. So as it learns, as it starts to hitting a lot more cheese and switch, that's when you see that the values start to go up to positive values. And that's what you want to see. Right, and the episode just basically means that how much time now it spends to hit the cheese and switch. By right, these things should just go from like really high, and which means that it takes a very long time, and then it starts to gradually decrease the time to decrease to finish the task. This one it goes up and down because it's still trying to figure out how it's going to work. Now, if everything done correctly after about 2 hours or 60 minutes, or even sometimes depending on what score that you put in for reward and penalty, you may get some. You might get it done in about less than an hour or 2. So that I'll let you all to experiment with that. So if everything done correctly, you should see something like this, right? If you see the graph that looks similar to this, good job. Then you successfully train the mouse, and the mouse will be an expert when it comes to locating locate the switch and the cheese. Okay. So then after that, once you complete the training, and the mouse should then you generate what we call a train model. So this train model is what you're going to use in the games or later on in the competition too. But I'll review how it's going to work. So yeah, so this is the part there when you have to grab that, take that result, and then integrate that to your mouse to see how your mouse perform or see what's the result of your training. So let's do that. All right. So to stop the training, you can just easily do just click the play, just stop it, and that's it, done. And you go back to the trainer that you just run. We are reaching close to our break. So in 15 minutes time, we're going to have our break. Okay. So and the part there, when it comes to the break there, right hand is going to guide. It's going to give some instructions about what it's going to do later on for oh no, sorry, it will be some links and something to do with feedback. Yeah, so she will tell you more about that. Okay, so in 15-minute time, so we're gonna have a break. Okay, so where was I? Right. So so here we stop the training, and then now it's telling you that okay, yes, exported the result, and also has also what do you call it? Copied the train model to this folder, right? So now if you go back to the train model, just go back to your Imagine Release 17, go to results. And notice that the name right here is the same as the ID that you input later on, earlier on in the command. So yeah, so this one, if you input a different name, then you have another name. So in this case here, we have cat and mouse run. So open up, and you want to see what you want to locate is this file. It's an ONNX file that is your result file, and that's your train model file. So what you do, right? So you just click and drag. Now I want to only test on just one. Let's test on one mouse. Okay, I just want to see what this mouse is going to do, and just click on that and right click, select the mouse. Right, just make sure that you have you're focusing on the behavior parameters, and that's the part that you want to put in. So what you're going to do is that open up the cat in the project hierarchy. This is what you call a project folders. Just make sure that you expand the cat and mouse and look for TF models. Okay. So what I'm going to do here, if you don't see if the names are if the file names are kind of obscure, you can just click on this, drag the slider so that you can see that more, right? More from the name properly. So the default one that we use for these demonstrations now is cat and mouse default, but we want to use the one that we train. So what you do is that you open up the folder, select the cat and mouse ONXX file, drag it over into these windows, and then just release it. And now it's copied to the Unity editor. Now the next step is that you drag the cat and mouse again, but drag it over to these field, right? And release it. And now you can see it's being replaced with the train model that you trained earlier on. Now, so what are you going to do? So that's it. Basically, you don't. Basically, what's going to happen now is that when you run it, you're using the train model that you made early on, and then the mouse will try to locate the cheese using the train model that you made early. Of course, we only train for a little while, and that mouse is gonna do a lot of things because you need at least about an hour, or at least an hour to see the actual result, right? But I do have the actual result, so I'm going to show you a little bit right there to see what is the expected result that's going to look like. I'm going to show you my Pro mouse, right? Yeah, that's my Pro mouse. What is that? Okay, I call it specialist, right? So it's a nice specialist mouse right here. So I'll just drag it over there, and right here. Okay. That's it. Just run it, and then you just watch your mouse blazing through. Oops, sorry. So you can see that the red switch right there is located, and then you're going to turn, and it's still going to back for a little bit, but the moment the red is in its line of sight, you just go for it. So red switch right away. Red. If the cheese is not within the line of sight, of course you're just going to miss it, but you will just keep looking around, and if it's out and it finds it, just go for it straight away. So this is pretty promo. So just now when you watch that in the training mode, so everything looks kind of hyper speed, right? Yes, because in training modes, that's something that we actually I told you about the config file. Yeah, in the config file, we changed the setting right there to tell the mouse to say, please train at about, I think 10 times the speed. It's really, really hyper speed right there. So it trains really, really fast. But when it comes to the part where we actually implement the train model to it, it will just go back to the normal speed. Yeah, so in this phase right here, we call it inference. So what inference does means it just essentially means that taking the train models and then basically just apply to the agents and tell agents that, okay, run with these optimal instructions. Okay, all right. So yeah, so this is how it should look like. But that's because because this is only just because I train it with only for the red mouse, because so the red mouse will only go for the red switch. But what happens if you tell that this blue mouse to say, hey, I want you to use the same thing too, and guess what's going to happen? Well, see that. So blue mouse is going to go for blue switch and blue cheese, and watch what's going to happen here. So you can see that the mouse is moving around. This is a cat. Okay, so it will avoid. But here's the thing: is that it's the instruction I gave. The blue mouse is supposed to only look for blue switch, but the instruction that I give, but the instruction right here, that the most optimal move that you train to is to look for the red cheese and the red switch. As you can see that it's actually going for red cheese and red switch, and it's not doing anything. It's just not able to complete the task. I can say, this is not its expected task. It's supposed to go for blue and then hit the blue cheese. But because blue switch is just in its way, and that's the reason why it hits the switch. And it's not because it's looking for a blue switch. So you see the difference right there. So basically, what really happens here is that you train the mouse, you assign a color to it, and the mouse will do its job, and it's just really gonna hit the colors that it's been trained to do. So how you're gonna make all these mouse to hit the right switch? Well, just now the same thing I told you before is that the red mouse are assigned to hit the red switch, and you train the mouse to do that. Then you create another ID that tells the mouse to only train to hit the blue switch and cheese. And same goes with the green and yellow. So basically what it means is that you're going to have 4 different sets of training models, or each model for each different color mouse, right? So take note this one. This is actually very, very important when it comes to the competition later on too. Okay, so we're very close to the break. And so let's see what else we have right there before the break then. So what you see right here is actually it's all in hyper speed. Oh yeah, I forgot to tell you one thing, how you actually can train more of them. So for example, let's just say, right, I want to train faster just for the red mouse. So what I do is that I'll just duplicate it, right? The easiest way to do is select the whole map and then just do Control D, you duplicate it. Let's drag it there. So you have 2 scenarios now. Drag another one, 3 scenarios. Drag another one, 4 scenarios. Now you train 4 times faster. But what if I do 20? Well, select all of them, copy, duplicates. Now you have 4 duplicates, drag it up there, right? Do another time. Now you have 12, drag another time. 16, duplicate another one. Now you got 20. So now I can actually ask this mouse to train 20 different scenarios in a matter of 5 minutes. That's basically will speed up your training. Okay. All right. So so during the break right there, that if you do have any questions, you can actually post right there. Then I would let me just see. Please give me a second. Okay, yeah. So we now we're going to. I think we can actually start to go for a break. I guess that you can start to go for a break, or you can actually just just look around, or and see if you can find any or figure out questions. Right. So after we come from a break, if I have any questions, I can take a very short ones. I just take about a couple of questions, 5 minutes. Right. Okay. Okay. Pass it back to Rehan.
Okay, thank you, Danny. All right, so everyone, we will go for a very short break for about 15 minutes. I understand that most of you do have questions to ask, and we will try to address them as much as possible. But in the meantime, I'm going to post a feedback form link available in the chat box right now. So I will need, it would be great if you can help us to fill up the feedback form. We will try to address the questions as much as we can. Also take note that this is a recorded seminar, so that means there will be recording available later on a later date. Okay, so have a good break and come back in 15 minutes and also help us to complete the feedback form. Thank you, everyone. All right, welcome back, everybody. And we will now resume the seminar. I will now pass on the time to Mr. Danny to continue the session.
Okay. Hi, everyone. I'm back. So let's just do this first. Okay, so just now I mentioned that after the break, we will take about for a couple of questions that so one look at here is that I have a few, I've seen some most of you having some errors right there. Unfortunately, there's some of these errors like regarding with the PyTorch installations. That one I'm not sure what really happens because it could be very different from one piece to another piece. And what I can see is that it says it couldn't find certain packages. So that basically just means that it's there are packages that are supposed to download, or you may have some internet connections error. But what I can only recommend is you can try to reinstall, start the same installation again and see if that will fix the issue. If not, then you will have to uninstall Python and reinstall Python again, because the installation of PyTorch usually is related because of Python. So you can just try that and see if it worked out. I think there's one question regarding about how you actually move the mouse, I think. Let me just try to find that again. I'm not sure I think there was one question. Yeah, there was one question about how actually you move the mouse and how do you actually make the mouse decide to move. Well, you don't really have. What I can say is that you don't have the controls of like telling the mouse where to move, but you can only tell the mouse to say the mouse will decide. Like the agent will decide where to move. So just now on the part there where we do the setting for the reward and penalty. So basically that how you decide, give like, encourage, so say for example, like to say move faster or move slower or not to avoid these completely. It's like, like it depends on how many points that you assign to the reward. For example, the example is that if, let's say, for example, if you assign a penalty to the mouse for the cat, say, for example, like -10, and what's going to happen here is that the mouse most likely will not move at all because it knows that the moment it moves, that because the penalty is so great to the point that where it's very risky for me to make any move. The moment I hit the cat, I will get all this penalty right there. So that's how actually it uses those points to decide what's needed to do. So in those 4 parameters that you're going to set is that there's a balance right there. So you need to find yourself that how much reward you're supposed to give it to encourage it to move forward. So move forward and go for the and complete the task, as opposed to how you would how much, like say, if the risk is too high, I'm not going to move at all. So there's really a balance right there. You need to you need to figure out yourself right there. But what I can tell you is that don't don't go with with those like very fast spectrum. Like, for example, like the cheese going to be like +10 and then the mouse going to be -10, and because the spectrums are so wide that the mouse will not be able to, most likely the mouse will not be able to move or not going to decide what to do, because there's just so many. It's still deciding what to do because there's so many decisions to make at one time, and that could hinder its learning process. Yeah, unfortunately, I won't be able to answer some of those questions that regarding with some errors, like with scripts or licenses, or in some of these instructions with PyTorch, because most of these they are really automated things, so there might be some issues where I'm not entirely sure or know what your PC or your laptop have installed, and they make that could cause the issue. And then there's another one. So there's one question right there. There's one question about, I'm running a Unity training, but the CMD is not picking it up. Right. Okay. So there are times when you look at the CMD, which is at the start of the game, you're probably going to see this thing at all. So if you don't see this, that most probably it's that when you start the training, when you run the command to train it, and then it's listening for a port, and what happened that it's either this port is being blocked by your antivirus, or it could be blocked by something else, or one could be a reason that you start this thing and then you wait for you wait for too long, for 5 minutes, and then the thing just timed out, and then so that it will not connect at all. So once you start that, you will usually have about a minute or two to connect, to play the button, and so that the trainer will start to capture, start to connect with the Unity's editors and start the training process. Sometimes you look at it, right, you get these coming right here, and they say there's nothing, that you don't get this reward coming up. That's okay, because usually if you only train with just only 1 scenarios or 4 scenarios, it usually takes about 5 minutes before it starts even before the first line will appear. But if you train with, just like I told you, like 20 different scenarios, you will get these values to come out like in a matter of like 1 or 2 minutes, because that's just how fast you're training it. And then that's how frequent you're training it, and then you're running through what they call it steps. So this is what they call cycles. So each time you complete 1 scenario, that's 1 cycle. So it's actually going through like 30,000 cycles in a sense. So depending on how many scenarios you train, that it potentially will affect how fast this thing will appear. There's another one. So when we run the program earlier, there was ML scripts taking into considerations the mouse colors, cheese colors. So regardless of what color we eventually choose, the agent would know which to search for. Or do we end up with a scenario like you showed with a blue mouse searching for a chest? Okay, that's a good one. So just now when I told you that if you train the mouse, like say here, and then so what's going to happen here is that let's do that, right? So if I choose this mouse and then say to red, okay, and then when I run the trainer will only train the mouse to look at one color, one specific color that you choose right here. So just red switch and red cheese, okay, and avoid the cat, of course. So if you want to train the mouse to look at, say, a blue color, then you have to run the trainer with a different ID. So like, for example, right here I can say, I want to run the cat mouse for red. You run a training, leave it for about 2 hours to stop it, and then you save, and then you run another. Then you run it with another ID. Let's call it blue. Say, and then you run blue, and then you go with green and go with yellow. So now you have 4 different sets, four different train files. So each of these files is correspond to the color that you train to. So the red one means that the red mouse is a pro, looking for red. The other one is just be blue, pro, looking for blue, and green, and so is yellow. So that's basically. But if you do this, for example, for mouse, right? Each mouse you assign with different colors. For example, let's say this one goes for blue. So what's going to happen here is that the trainer will look at all these four mouse with four different colors, and what is going to happen is that it will not the mouse will not be trained to specifically look for one color. Now the mouse is trained to look for all colors and just go for all colors and go for all cheese. You see what I mean? Right? So that's the difference right there. How you configure the way how you train it and how you want the trainer to train. It makes a difference about how the mouse going to behave as a end result. Okay, I hope that answers the question. Okay, how do we view the graph on Mac? I'm not really familiar about how Mac's really gonna work, but really according to the Unity, the officials website for this toolkit, usually what you can do is that if you can open up the terminal and if you type in the same command, like these TensorBoard, because these usually, if you install this package correctly, it uses the common tool called TensorFlow, basically Python script basically. And if you run the same command, I'm pretty sure in Mac it's going to be pretty much the same command that you're going to run. If you run this, you should be able to view the graph in Mac. I'm really sorry, I can't really help with Mac because I'm not really familiar with this one. But if you go to the official website, which is I'm going to type in there, I can actually share with everyone. Just give me a sec. There's I have also put this actually in the agent. So this project, the demo that I'm using with Cat and Mouse is actually uses these ML toolkits as a base. So we just add our stuff in it. So if you follow the instructions, you should pretty much be able to reach the same conclusion. The release that I'm using here is release 17. So don't try to go with 16 or 18 or anything lower than that. So use the one release 17. So that's what you should look for. So just click on documentations and you should be able to get the installation right here. I should have some installation right here, which is for Macintosh. So you follow that, it should work. That's pretty much the same. Okay. Yeah, I think that's it. We'll have all the questions already, and then we're going to do the some bit of a demonstrations. Okay, so as you can see, like I say, the package that we use, right, is from Unity Toolkit, right? So so Cat and Mouse is just really one of those things that Cat and Mouse is just one of those games that we develop in our lab. Sometimes we're just going to have some fun, try to create different things using machine learning for different purpose, or train how the plane's going to fly, train the drones on how to locate patients or locate survivors in certain disaster scenarios, kind of thing. So this tool right here use Unity's with machine learning. It's not only just for games, but usually are for some real world purposes too. But those are, but enough of those boring stuff right here. But all you want to come is actually, you're coming here because of machine learning for games. So I'm going to show you something that is a bit more interesting right here. So if you notice that inside there's a folder called Cat and Mouse, and then there's ML agent, right? So this is actually the core that we're using that's from Unity. And if you click on the example, there are a whole bunch of other things you can play around with too. Now, so if you say 3D balls is like the very most basic thing, and some of you probably have seen this before, but let's just have a little bit of fun with this one. So so if you do, so when you click on this one and you just click play, and what this does is that the machine learning will learn to balance the ball on top of its head and keep the ball on top so they will not drop. And that's what it's going to do. So if you train it well, and then you see the agents are all of them can balance the balls on top of its heads. And it's just one thing you can do. And you can also retrain the agent again just to put in your own values, and you can explore these, experiment with yourself too. Okay. That's the very basic one. And then there's something very more interesting one I would like you to watch. Soccer. I think it's called soccer somewhere. Soccer is everyone, most of us, most of us knows about soccer. Then when you say soccer games, football, it's Southeast Asian stuff, right? So we're all kind of like favorites. So if you run this, and you can watch them. This is where you can have competition. You have two competing teams, a team A, team B, and team A will try to score, and the team B will be like I'm sorry, I guess I think there's some error there. Oh, sorry, choose the wrong one. Let's go with some soccer for two. So you can watch that two different teams trying to score the goals. So you have players on each side. There seems to be some errors with the. Now this is what happens when you don't assign the correct model. So what happened here is that there's a missing models right here, but that's okay. We're just gonna let me assign it just to show so that you can see what's going to happen right here. So purple striker, and then blue striker. And purple striker. Okay. So you just need to concentrate on one of this area, not all of them. If we assign it correctly, all should work. There you go. Right. So you can see that they're all starting to compete each other, and they try to score. The blue one tries to score to this goal, and the purple tries to score this goal. So you can see that the blue have no. It does not have a very specific role. So they each play the role of strikers and goalie depending on the situation. So like, for example, like when the ball has crossed the middle line, all blue players will become strikers and try to get the ball in there. And then the purple will become defenders and the goalies. So they change role depending on what happened, what's the situation. And you can see that they actually adapted very quickly depending on that situation. So this is a very good example about how some of those games that you see like in Dota, like how the AIs actually adapt to the changes in environment, how the player when the actual human player react to say perform certain actions, the AIs will decide what's the next action to counter or to perform in that situation. There's a lot of others example right here, so you can go and explore it, play around it, and also just to be clear, and also so just so you guys know, that everyone knows as well that the game that we make cat and mouse, it's actually we're using the pyramid. It's using a pyramid algorithm. So the algorithms that we use in pyramid right here, this game is a reinforcement learning. So you can read more about that. I think there's some documentation in there too. You can read that, so you can understand a bit more about reinforcement learning. And you can see that reinforcement learning algorithm is being used by in a lot of simulations and a lot of machine learning in most cases, right? And not just for games, but in most of the times when you do about just to do object recognitions, sometimes they use reinforcement learning too. So reinforcement learning is very common, but yet it's not very well understood at the same time too. So it's very hard. It's not easy, but it's very interesting. It's a very interesting topic when it comes to machine learning. All right. So then let's just see what else I can show you guys here. Oh yeah, and then I forgot about the there are some learning reading actional ring. So it's just really some, you know, like you want to learn more about reinforcement, which is the algorithm that we use for cat and mouse or to get the cheese game. And then the beginner's guides, and this is just really some of those examples, and you know the more information about the details of how they actually implement these algorithms into games like Mario or even Dota. Dota is using a different algorithm. Dota is using, if it's not wrong, using dance or something. It's something that it's more complex, more like a deep learning AI. So that's another branch of machine learning, which is which actually can handle more complex decision makings, and it's almost, but if you train it really correctly, it's almost like human. You're almost like you're playing against a human right at all. So if you watch the videos about the Dota's having open AI with Dota, the way if you don't know, if no one tells you that the other person on the other side of the screen is an AI, you couldn't even tell the difference at all. It's just so good. It's playing. It mimics the player's movement. It mimics the player's behavior. Some even picks up the player's behaviors in a certain way, and it tries to it can even sometimes when you play certain games, and if no one tells me that, oh, that's actually AI, I would think that that's actually some other top player that I'm playing against with, which I don't know which name of it, but it's very, if I'm familiar with certain moves or certain tricks and stuff that the players actually perform, sometimes the AI will pick it up and it will mimic that kind of movement too. There are also machine learning is also the another interesting part about machine learning is that it's there's another called the mimic algorithm that it copies exactly every single move of a person. Say for example, like in F1. So this is actually being used by F1 right now. It's like, you know, like Mercedes, they train Lewis Hamilton. So what happened is that they took his data of his race from all around the world for the whole year season, and they pump it up into the machine learning, and the machine actually learns, mimic and copy his moves, and so that when they put into simulators and sort of like, and then ask Lewis Hamilton, okay, now you have to beat yourself. So each time you want to be a champion, you need to be better than yourself. So what happens is that the machine learning learns about the player's move, his tricks, and comes to corners and things like that. And yeah, and basically that's how they train the F1 drivers nowadays. So it's all machine learning. And even some of those machine learning that make, say, F1 like decisions that when to come into, say, when to pit, when to change tires, when to fuel the cars, like when do you drive faster, when to drive slower, go which corner. All these things are all nowadays are all in machine learning and stuff. So yeah, so in game labs we make a lot of this research when it comes to so we're doing some research as well about for other serious gaming simulations, but the best part about it is in what we do in game labs is that we always want to make some games that it's more interesting, it's like something fun. So that's why, and hence why we get the cat and mouse cheese, just to see how can we actually use that mouse to do something fun. But of course, we do have other projects as well that's actually using machine learning, but unfortunately, those are more classified games. But again, but we can tell you one thing is that those are the simulations that we use mostly for the real life simulations, for drones and for all the disaster situations. Okay. Yeah. So if you really want to know, like, so if you want to see more about, or you want to check out, like, if you want to know what we are doing in game in the future, like, see, we're going to come up with something new for machine learning, you can always come and check out our website, and or even, like, just follow us on Twitter and Facebook. So we, whenever we have something news about what we've been doing with developments, we will post something new. We'll post it right there, and then you can check it out, those projects and then for now that we're doing some revamps in our website, so there's not a whole lot of things going on at the moment. So because of these years that we've been, COVID-19, and we've been revamping the way how we actually want to reach out to people and how we want to, show some of those cool stuff. So we're doing some renovation right there. So just rearrange things. But yeah, soon. But if you follow us on Twitter and Facebook, then you'll be able to get those updates right there. Okay. Right. So we're great. So we can now actually roughly in about 5 more minutes, we're gonna do the unveiling of the grand challenge. Now this is so you have about, so you're gonna have about 2 weeks there to train the mouse and to be the best one and then crown you. So so let me just prepare a little bit right there to show you.
Okay, so I hope all of you have already gained much information on machine learning and Unity, and it's time to proceed with the game challenge unveiling. So Danny will be explaining to you more on the game itself and what to take note of, the rules and regulations, and how it will actually look like on that day itself. And then following which, I will brief you on how you can actually register and sign up, and more details will be coming up later on. We will also unveil the prizes that you're going to win if you participate and win the top 3 prizes. Of course, all participants will also get something from us, even if you do not win the competition. So stay tuned. Danny, once you're ready, are you ready to actually speak more on the game challenge itself?
Yes.
All right, good. All right, let's begin the game challenge unveiling. Let's go, Danny.
Okay. All right. Okay, so we reached the point of grand challenge. So this is where we'll put those mouse that you train to the test. Okay, so the grand challenge is a competition to crown the best trained mouse. Okay, so given, we're gonna use the train agent file, which is just I will show you earlier, like the extension file ONNX file. From the Get the Cheese trend demo. So we're going to use that. So when you train your mouse and it generates that file, those files, we will use those for the competition. The competition uses a playoff format. So it's like elimination rounds, or like or such like how you watch football, and we have there'll be a group, right? So everyone starts in a group or individuals. If you don't have a group, so you're going to be individuals. So basically, I'm sorry. So what I mean is that a group means that there'll be, say, 4 participants. So each participant could be a team or could be individual, doesn't matter. So let's just call the participants, right? So participants will be about 2 up to 4 in a group. And then the winner of that group will move on to the next round and compete with the rest of the other winners from the group. Okay, and then we just keep doing that eliminations all the way up to finals. Okay, so each participant will be assigned a color to their respective group of the round. So remember just now when I mentioned there are 4 different colors right there. So red, blue, green, yellow. So each round you'll be assigned to a color. It does not mean that when you assign red color at the start, it's going to be all the way up to the finals. It's going to be red. No. So each round you might be assigned to different colors afterwards. Okay, so let's say you in round 1, for example, you're assigned to red color, and then you say you win, you move to round 2, and round 2 you may be assigned to blue or yellow or green. Okay, so that's what red means. So remember, you have to train your mouse. So remember to train your mouse to be the master of all different colors. The layout of the competition maps and difficulty may change in every round. So the map that I will show you is just really the default map. But more information about those maps or how we're going to look like is going to be as we get closer, or on the day of the competition. But we can tell you one thing is that the map size that you're looking at the demo. These are 4x4. This is a 4x4 size, we call it. Okay, so 4x4 size. So the maps that you'll be competing, it could be 4x4. It could be also 6x6. So the up to maximum 6x6 size map, right? So the layout is a secret, but your mouse should be able to handle that situation. So you have to train your mouse and see if you can in those situations. Yeah, one thing I need to mention to you as well, that because of the layout can change, you may change the layout in the map in the get the mouse, so that get the cheese, sorry, to get the cheese, you can change the layout a little bit right there, but don't touch the cheese, the switch, and the cat. But you can change the layout of the map and you can still train the mouse, right? That's keep here. Okay, and last but not least, in the final, only the top 3 participants win the prize respectively, but only the best will be crowned within the 2021 Grand Challenge. So what it means is, there comes a final. Instead of the winner of each group, so at the final right there, we will have winner, runner-up, and first runner-up to win the prize. Okay, so the top 3. Now, how that playoff format is going to work, that's pretty much it. Most of you already know. So I'll just show you, just to give you some idea about how it's going to work. So you can see that player 1, 2, 3, 4 in one group, player 5, 7, 6, 8 to one group. So each of them, say player 1 is a winner of that group, moves on to the next round, and then form another group, and then playoffs again, and then go up to finals, and then that's when you decide the first, second, and third winner right here. Okay, but we don't have second right here, but you get a point. Okay. So submission and rules. So in those coming days, we will assign you a folders, right? So this is where you're gonna upload your train model folders in here, right? So so you can't see any others. So this is actually a folder that's only for you, right? And no one else. No one else can see this folder. Of course, I can see that too, but what it means is that only you can see that. So you're gonna submit that files in that folder, okay? And the train file agents ONX files must be submitted to the folder assigned to you by 12 p.m. on July 30th, right? That's a final submission date. So I'm gonna make sure that, so if you submit anything later than that, I'm sorry. So you will be disqualified from that. Or, right, if you only submit just only one file, then yeah, so be it's one file. So if so make sure that you test your files, right? Your trainer files properly, right? Make sure you test it all over again. So even though if it's uploaded to the folder, make sure you download again, just try again to make sure that it's not corrupted. So if it's unusable or corrupted, then you'll be disqualified. Okay. And yeah, and that's pretty much from me. That's really and then if there's any questions at all, and but yeah, so okay, I can take in some questions from this onwards. Like for example, you have any questions regarding the Grand Challenge, you can post right here, and I'll try to answer as much as I can. So I think the first one already in. So you asked to say the individual is a team challenge. I think it's up to you.
Yes, it's up to you. So Danny, I will take on from there. Thank you so much.
Oh,
Danny.
yes, right. Yeah, I'm not right.
Yeah. No worries.
I'm taking over your job. Oh, sorry for that. All right, Ryan, we go to you.
Okay, great. So thank you so much, Danny. So Danny has really revealed some of the important notes for the Grand Challenge itself, but I will be revealing on how you can register and what to expect on and everything else, okay? So what's going to happen here? So for the Grand Challenge, the title for the game challenge itself, it's called AI for AI Game Challenge, Grab the Cheese. So as mentioned by Danny, you will have Agent Mouse to grab the cheese by going around the maze, making sure that you find the switches to activate or basically reveal the mouse before the other team can get the mouse itself. And there'll be cats around. They are hungry for the mouse. All right. So you must make sure that you navigate them properly before they get to make sure that they get through cheese instead of the cat. All right. Now moving on. So what's going to happen here is that on the day itself, the registration will be revealed today. All right. So who can participate? This challenge is open to all pre-university students, aged 16 to 21 years old, including NSF. So you do not need any prerequisites. All right. Each team member only one team member is required to should have attended the introduction to the game development webinar, which is today. So if you're actually applying as a group, one team member should have attended today's webinar. Okay, so the other team members can be your friends who did not attend today's webinar, but you can all form a group of 2 to 3 or 4 packs and apply for sign up for the challenge itself. But if you're also applying as an individual, that's also fine. Okay, so the link to the recorded session, which is today, will be made available later on a later date. Okay. So these are some of the important dates that you need to take note of. So those who are interested, kindly screenshot or take a picture, because these are the dates that are very, very crucial. So today will be basically today is the webinar itself. After today, later on, I will share with you the link to sign up. And once you actually receive the link, you need to form teams of 1 to 4 and sign up for the link. As mentioned, we only require 1 entry team. Now, something exclusive is that the first 10 teams to register will receive a one-to-one private mentoring session with Danny and SUTD Game Lab. So this is your chance to actually grab the slots as fast as possible so that you can train your agent. And in the meantime, you have questions before the submission. During the one-to-one session itself, you can ask questions and make sure that your agent appears to come out to be the best agent. Okay, and then from today until the submission date, which is stated on the screen, which is on the 29th of July. Yeah? So instead of 30th of July, just take note, it's 29th of July, 11:59 p.m. This is where you submit your file agents through the drive that will also be shared with you after you have signed up. And then the game challenge day will be on the Saturday, 31st July, from 9 a.m. to 12 p.m. All team members are required to be there so that you can observe and see your agent mouse perform on the day itself. Okay. So moving on as well. So what will you get, or basically what will I receive if I participate in the program itself? So all students will receive or all participants will receive a certificate of participation. Just take note, for if you are attending today's webinar, you will not be receiving a certificate, but if you participate for the game challenge itself as a participant, you will receive a certificate of participation from us, an e-cert, just for your information. And then let's move on to the exciting part. Okay, so what will motivate you, or basically what I hope you will take this opportunity, because there are exciting prizes to be won. We will give out prizes to the top 3 teams. So on top of getting a certificate of participation, you will also be receiving prizes for the top 3 teams. So let us reveal what are the prizes coming in 3rd place. We have a Studio Neo True Wireless earbuds and also a certificate of achievement. So you get 2 sets with a studio earbuds, all right? So I'm pretty sure all of you have seen this somewhere in Instagram. It's pretty much hyped, especially in terms of the latest earbud production. All right, coming up 2nd place, you will get a Samsung Active Watch, Active Wear 2, all right? And also a certificate of achievement, all right? And now for the 1st place, we're gonna be awarding you with a Samsung Galaxy Tab S6 Lite Wi-Fi version and also a certificate of achievement, all right? So I hope all of you are pretty much motivated for the game challenge itself, okay? So all this information will be available on the website itself, and the link to the registration is now available on the chat, so you can scroll in, register now, sign up, and then submit the form, and then we will get in touch with you on it. Okay. Now I will leave we will now proceed on to a little bit of Q&A if you have any questions before we close the session. Okay, so some questions asked is prizes is shared with the entire team, or is it per person? So as mentioned, if 3rd prize you get a studio, of course 1 person will get each one. Okay, so you can't share one between 3 to 4 packs. Each person in the team will receive 1. Okay, so same thing, 1st prize, each person will receive a Samsung Galaxy Tab. All right, and then okay, good. Let me just see the Q&A session. Okay, so if you have any questions regarding the technical side of today's webinar, you can always drop us an email later on. If you do have questions regarding the game challenge, also you can drop us an email later on. Just to take note that this is those people who register for the webinar, sorry, the game challenge, and if you're the first top 10 teams, we will also get in touch with you with the mentoring session itself. Okay, so Danny, would you like to add on anything else?
Yeah, there were some questions that I think someone opened up the file,
Okay.
and then there was some issue with the version. So you were mentioned that you opened the file with the 2020 versions and the file is actually in 2000 version. Don't worry about it. It's just really a warning, but you can just proceed with that. No issue at all.
Okay.
Okay.
Good. Okay. So if that's the case, then I believe we have come to the end of the session. All right, before we end off the session, we would like to just say once again, thank you so much to everyone who participated in this webinar, and I hope you have enjoyed the session today and gain more insights on the application of machine learning in gaming and game development. Also, I would like to take this opportunity once again to train our trainer for today, Mr. Danny. So thank you, Mr. Danny, for the wonderful sharing, and we hope that all of you will continue to participate in the game challenge because there'll be the exciting prizes. I hope to see you on the 31st July itself, where we will watch each other's agent battling out each other in the maze and see who will emerge the top 3 teams. So without further ado, I would like to say once again, thank you so much, and also kindly to fill up the feedback form that will be available later on the slide. So with that, thank you so much for spending time with us on Saturday, and we hope that you have a great day ahead. Thank you, everybody.
Okay, thank you.